What if humanity's next chapter isn't written on Earth? As we face the growing challenges of climate change, overpopulation, and dwindling resources, the idea of becoming a multi-planetary species is no longer just science fiction, it's a necessity. But here's the twist: the key to our survival might lie in transforming two of our neighboring planets, Venus and Mars, into worlds we can call home. This isn't just about finding a new place to live, it's about reimagining what's possible for the future of humanity. Could we one day breathe on Mars without a spacesuit? What would it take to cool down the scorching heat of Venus and make it habitable? These aren't just hypothetical questions, they're the driving force behind some of the most ambitious scientific endeavors of our time. In this video, we'll explore the mind-blowing technologies, the monumental challenges, and the incredible possibilities of terraforming Venus and Mars. From atmospheric manipulation to creating artificial ecosystems, we'll take you on a journey through the cutting-edge innovations that could one day turn these alien worlds into thriving havens for life. So buckle up, because by the end of this, you might just see the solar system in a whole new light. The dream of terraforming, reshaping hostile worlds into Earth-like havens, has long captured the imagination of humanity. But where did this bold vision begin? Surprisingly, its roots stretch back not just to modern science, but to the pages of science fiction. Early writers like H.G. Wells and Olaf Stapledon painted vivid pictures of transforming alien landscapes, planting the seeds of an idea that would grow far beyond the realm of fiction. One of the first to bring terraforming into the scientific spotlight was Carl Sagan. In the 1960s, he proposed a radical idea: altering Venus's atmosphere to make it habitable. Sagan's work sparked a wave of curiosity, blending the lines between speculative fiction and serious science. Decades later, authors like Kim Stanley Robinson took the concept even further, crafting detailed narratives in novels like the Mars trilogy that explored not just the technical challenges, but the social and ethical implications of reshaping entire worlds. What began as a fantastical notion has steadily evolved into a field of serious scientific inquiry. Technological advancements in fields like atmospheric science, robotics, and climate modeling have turned what once seemed like pure imagination into a plausible goal. Experts now believe that with the right tools and enough time, we could one day transform the barren landscapes of Venus and Mars into thriving ecosystems. But this journey from fiction to feasibility hasn't been without its skeptics. Critics argue that the challenges are monumental, from the lack of a magnetic field on Mars to Venus's crushing atmospheric pressure. Yet, as technology continues to advance, the dream of terraforming feels closer than ever. As one scientist put it, the impossible is just a problem waiting for the right solution. So, what makes Venus and Mars such compelling candidates for this ambitious endeavor? Each planet presents unique opportunities and hurdles, shaping the way we approach the dream of making them habitable. From the sulfuric clouds of Venus to the dusty plains of Mars, the path to terraforming is as complex as it is thrilling. And as we'll see, the challenges we face today may one day become the stepping stones to a future among the stars. When we look out into our solar system, two planets stand out as the most promising candidates for terraforming: Venus and Mars. But why these two? What makes them more feasible than, say, Mercury or Jupiter? The answer lies in their unique characteristics and the challenges they present, challenges that, while daunting, are not insurmountable with the right technology. Let's break it down. Mars, often called Earth's little sibling, has long captured our imagination. Its thin atmosphere, made mostly of carbon dioxide, means it lacks the protective shield we enjoy here on Earth. Temperatures on Mars can plunge to -80 degrees Celsius, making it a frigid, desolate landscape. But it's not all bad news. Mars is relatively close to Earth, with a distance that allows for more frequent missions and easier communication. Its day is just slightly longer than ours, and it even has polar ice caps, potential reservoirs of water, a critical resource for any terraforming effort. Now let's turn to Venus. If Mars is Earth's cool, distant cousin, Venus is the fiery sibling you don't want to get too close to. Its surface temperatures soar to a scorching 460 degrees Celsius, hot enough to melt lead. The atmosphere is a crushing mix of carbon dioxide and sulfuric acid clouds, creating a runaway greenhouse effect that makes Earth's climate change look mild by comparison. But Venus has its own advantages. Its gravity is nearly the same as Earth's, which could make long-term habitation easier for humans. And while its atmosphere is a problem, it's also a potential resource. If we could find a way to break down that thick blanket of carbon dioxide, we might just unlock the key to making Venus livable. So why not other planets? Mercury is too close to the Sun, with extreme temperature swings and no atmosphere to speak of. Gas giants like Jupiter and Saturn lack solid surfaces, making them impractical for human settlement. Venus and Mars, despite their challenges, offer the best balance of feasibility and potential. Mars is cold but familiar, while Venus is hostile but brimming with untapped potential. Yet, terraforming either planet will require groundbreaking innovations. From atmospheric processors to solar shades, the technology we'll need doesn't exist yet, but it's within the realm of possibility. And that's where the real adventure begins. Transforming a planet's atmosphere is the cornerstone of terraforming, and it all begins with atmospheric engineering. Think of it like this: before you can build a house, you need a solid foundation. For Mars and Venus, that foundation is their atmospheres. But here's the catch: each planet presents its own unique set of challenges. On Mars, the atmosphere is incredibly thin, about 1% the density of Earth's. This makes it impossible to retain heat or support liquid water, two essentials for life as we know it. To thicken Mars' atmosphere, we'd need to introduce greenhouse gases like carbon dioxide or methane, which could trap heat and gradually warm the planet. Sound familiar? It's similar to what's happening on Earth due to climate change, but in this case, it's a controlled process aimed at creating a habitable environment. Now, Venus is the opposite problem. Its atmosphere is overwhelmingly thick, with crushing pressure and temperatures hot enough to melt lead. To cool Venus down, we'd need to reduce its greenhouse effect. One proposed solution involves deploying massive solar reflectors in space, designed to bounce sunlight away from the planet and lower surface temperatures. Another idea is to introduce chemicals that could break down the dense carbon dioxide atmosphere into less heat-trapping compounds. These methods might sound like science fiction, but they're grounded in real-world science. In fact, Earth-based climate engineering projects like solar radiation management and carbon capture offer valuable insights into how we might tackle these planetary challenges. But atmospheric engineering is just the first step. Once we've adjusted the atmosphere, the next piece of the puzzle is water. On Mars, water exists mostly as ice in the polar caps and beneath the surface. If we can warm the planet enough, that ice could melt, creating rivers, lakes, and eventually oceans. Venus, on the other hand, has almost no water left. Its scorching temperatures boiled it away eons ago. Here, we'd need to import water from elsewhere, perhaps from icy asteroids or comets. Water isn't just essential for life, it also plays a critical role in stabilizing climates and supporting ecosystems. So, while atmospheric engineering sets the stage, water is the lifeblood that will truly bring these barren worlds to life. One of the most exciting discoveries about Mars is the undeniable evidence of water, both in its distant past and hidden beneath its surface today. Ancient riverbeds, dried-up lake beds, and mineral deposits tell a story of a planet that once had flowing water, possibly even oceans. But the real game-changer lies beneath the Martian soil, vast reservoirs of ice locked away in polar caps and underground glaciers. This frozen treasure isn't just a relic of the past, it's the key to unlocking Mars' future. Imagine the possibilities if we could melt this ice and bring liquid water back to the surface. Lakes and rivers could form, creating the foundation for life, not just for microbes, but potentially for human settlers. But how do we turn this vision into reality? One idea involves heat-generating satellites, orbiting Mars and beaming focused energy to the surface, gradually melting ice deposits. Another approach could use advanced drilling technologies to access underground glaciers, much like how we extract resources on Earth. These drills, equipped with heating elements, could tap into the ice and pump water to the surface, where it could be stored or distributed. To better understand how this might work, we can look to Earth's polar regions. In places like Antarctica, scientists have drilled deep into ice sheets to study ancient climate records and even test technologies for future Mars missions. These case studies provide valuable insights into how we might handle Martian ice, from managing extraction to ensuring the process is sustainable. After all, water is a finite resource even on Mars, and using it wisely will be critical to building a long-term presence on the planet. But water alone isn't enough. Once we have it, we'll need to create ecosystems that can sustain life. This means developing closed-loop systems where water is recycled, purified, and reused, minimizing waste and maximizing efficiency. Think of it like creating a miniature Earth on Mars, where every drop of water is part of a carefully balanced cycle. It's a monumental challenge, but one that could pave the way for a thriving Martian civilization. And with each step forward, we're not just reshaping Mars, we're redefining what's possible for humanity. Imagine a world where the tiniest organisms hold the key to transforming a barren, alien landscape into a thriving biosphere. This isn't science fiction, it's the potential reality of terraforming Mars or Venus, and it all starts with microorganisms. These microscopic powerhouses could be the unsung heroes of interplanetary colonization, laying the groundwork for life in the most inhospitable environments. But how? Enter extremophiles, organisms that thrive in conditions most life forms would find unbearable. From scorching hot springs to acidic lakes on Earth, these resilient creatures have already proven they can survive where few others can. On Mars or Venus, extremophiles could be the first settlers, breaking down rock, releasing nutrients, and slowly creating the building blocks of a new ecosystem. One groundbreaking experiment that highlights this potential is NASA's Mars ecopoiesis test bed. Ecopoiesis, meaning the creation of a habitable environment, explores how Earth-based microorganisms could survive and function on Mars. By introducing these hardy microbes into simulated Martian conditions, scientists are testing whether they can produce oxygen, recycle nutrients, and even pave the way for more complex life forms. It's a bold step toward understanding how life could take root on another planet. As Dr. Penelope Boston, a leading astrobiologist, once said, "Microbes are the ultimate pioneers." They don't just adapt to their environment, they transform it. But the story doesn't stop there. Synthetic biology, the science of designing and engineering biological systems, could supercharge this process. Imagine custom-designed microorganisms engineered to thrive in the thin atmosphere of Mars or the crushing pressure of Venus. These synthetic extremophiles could be programmed to produce oxygen, fix nitrogen, or even break down toxic compounds, accelerating the creation of a stable biosphere. It's a fusion of nature and technology, where biology becomes a tool for planetary transformation. As we consider the role of microorganisms in terraforming, it's impossible to ignore the bigger picture: artificial ecosystems. These engineered environments, designed to mimic Earth's natural systems, could one day sustain human life on distant worlds. By combining the resilience of extremophiles with the precision of synthetic biology, we might just unlock the secrets to creating a biosphere from scratch. It's a vision that challenges our understanding of life itself, and one that could redefine humanity's place in the cosmos. Now, let's dive into one of the most fascinating aspects of terraforming: building artificial ecosystems from scratch. Imagine creating a fully functional, self-sustaining habitat on a planet like Venus or Mars, where life as we know it doesn't naturally exist. This isn't just about planting a few trees or introducing some microbes, it's about engineering entire ecosystems that can thrive in the harsh, alien environments of these planets. To make this possible, scientists are looking at genetically engineered plants and animals designed to survive extreme temperatures, low atmospheric pressure, and high radiation levels. For example, plants could be modified to photosynthesize more efficiently in dim sunlight or to extract nutrients from barren Martian soil. Animals, on the other hand, might be bred or engineered to play specific roles in maintaining the ecosystem, like aerating soil or controlling plant growth. But creating these organisms is only half the battle. The real challenge lies in balancing these ecosystems so they can sustain themselves over the long term. One way to approach this is by studying Earth's closed ecological systems like Biosphere 2. This massive experiment in the Arizona desert aimed to replicate Earth's ecosystems in a sealed environment, but it faced numerous challenges, from fluctuating oxygen levels to conflicts between species. These lessons are invaluable as we look to build ecosystems on other planets. For instance, we'll need to carefully manage the ratio of plants to animals, the flow of nutrients, and even the microbial life that supports the entire system. Of course, none of this is possible without a reliable energy source. Whether it's solar power, nuclear energy, or some other technology, powering these artificial ecosystems will be critical to their success. Without energy, life, no matter how well engineered, simply can't survive. So, as we move forward, the interplay between biology and energy will be one of the most exciting frontiers in the quest to terraform Venus and Mars. One of the most critical factors in terraforming Venus and Mars is harnessing the power of the sun. Both planets, despite their harsh conditions, receive an abundance of sunlight. Venus, closer to the sun, basks in intense solar radiation, while Mars, though farther away, still gets enough sunlight to make solar energy a viable option. But how do we capture and utilize this energy effectively in environments so different from Earth? Solar mirrors, for instance, could play a key role. These massive reflective structures could redirect sunlight to specific areas, warming the surface of Mars or even cooling the upper atmosphere of Venus by blocking excessive heat. On Earth, we've already seen the potential of concentrated solar power in projects like the Ivanpah Solar Electric Generating System in California, where mirrors focus sunlight to generate electricity. Imagine scaling this up on another planet. Solar mirrors could not only provide energy but also help regulate temperatures, a crucial step in making these worlds habitable. Then there are photovoltaic arrays, the solar panels we're familiar with on Earth. On Mars, where the atmosphere is thin, these panels could operate even more efficiently than they do here. However, dust storms on Mars pose a significant challenge, potentially covering the panels and reducing their effectiveness. Solutions like self-cleaning coatings or automated wipers, inspired by technologies used in desert-based solar farms on Earth, could help mitigate this issue. Energy storage is another hurdle. The sun doesn't shine all the time, even on Venus or Mars. Advanced battery systems, perhaps using cutting-edge materials like graphene or solid-state electrolytes, could store excess energy during peak sunlight hours and release it when needed. This would ensure a steady power supply for critical terraforming operations, like melting ice or powering atmospheric processes. Distributing this energy across vast planetary distances is no small feat either. On Earth, we've developed smart grids to manage renewable energy flow efficiently. A similar system, combined with wireless energy transmission technologies, could be adapted for use on Mars or Venus, ensuring that energy reaches where it's needed most, even in the most remote or inhospitable regions. As we tackle these energy challenges, another piece of the puzzle comes into play: robotics. The sheer scale of terraforming demands automated systems capable of building, maintaining, and operating these energy solutions in environments too extreme for humans. From deploying solar arrays to repairing damaged infrastructure, robots could be the unsung heroes of this grand endeavor, working tirelessly to turn these distant worlds into future homes. As we look toward the future of terraforming Venus and Mars, one question stands out: who will do the heavy lifting before humans even set foot on these alien worlds? The answer lies in Robotic Pioneers, advanced machines designed to prepare the ground for human settlement. These autonomous systems could be the unsung heroes of planetary colonization, performing critical tasks like construction, mining, and resource extraction long before humans arrive. Think of them as the ultimate construction crew, working tirelessly in environments too harsh or dangerous for us to handle. Take NASA's Perseverance rover, for example. While its primary mission is to search for signs of ancient life on Mars, it's also laying the groundwork for future human exploration. Perseverance is equipped with tools to analyze soil, test oxygen production, and even collect samples for potential return to Earth. These efforts are more than scientific experiments. They're stepping stones toward understanding how we can harness Martian resources to sustain human life. And it's not just about Mars. Similar robotic missions could one day tackle the extreme conditions of Venus, where surface temperatures exceed 800 degrees Fahrenheit and atmospheric pressure is crushing. The key to these robotic pioneers lies in their advanced AI and machine learning capabilities. These systems are designed to adapt to unpredictable environments, making decisions on the fly without human intervention. Imagine a fleet of autonomous mining robots extracting water ice from Martian poles or constructing habitats using locally sourced materials. By delegating these tasks to machines, we significantly reduce the risks to human life, allowing us to focus on the bigger picture of establishing sustainable colonies. But let's not overlook the challenges. While robots can handle the initial groundwork, human adaptation to these planets will require overcoming immense hurdles. From the psychological toll of isolation to the physiological effects of low gravity, the journey to making these worlds habitable is as much about human resilience as it is about technological innovation. So, while robots may pave the way, the ultimate goal is to create a future where humans can thrive alongside them, and that's where the real adventure begins. Living on a planet like Venus or Mars isn't just about building the right technology. It's about redefining what it means to be human. The challenges we'd face on these alien worlds go far beyond the physical. Our bodies, for instance, evolved for Earth's gravity and atmosphere. On Mars, with its weaker gravity, muscles and bones would deteriorate over time without constant exercise or artificial support. Venus, with its crushing atmospheric pressure and toxic air, would demand entirely new ways of protecting ourselves from the environment, but the hurdles don't stop there. The psychological toll of living in isolation millions of miles from Earth could be just as daunting. Imagine being part of a small colony surrounded by an endless, barren landscape with no quick way to return home. The mental strain of such an existence is something we've only begun to understand, thanks to studies in extreme environments like Antarctic research stations or long-duration space missions. In these settings, even small conflicts can escalate, and the monotony of daily life can wear down even the most resilient individuals. That's why building a strong sense of community and prioritizing mental health would be absolutely critical for any future settlers. To tackle these challenges, we're looking at some groundbreaking solutions. Genetic modification, for example, could help humans adapt to lower gravity or resist radiation exposure. Advanced life support systems would need to be more than just functional. They'd have to mimic Earth's natural cycles to provide a sense of normalcy and habitat design. It would play a dual role, protecting us from harsh conditions while creating spaces that feel welcoming and alive. Think vertical gardens, communal areas, and even virtual reality environments to combat feelings of isolation. What's fascinating is how much we can learn from existing analogies. Take the International Space Station, where astronauts live in close quarters for months, relying on carefully planned routines and regular communication with loved ones to stay mentally healthy. Or consider the Concordia Research Station in Antarctica, where scientists endure months of darkness and isolation, offering valuable insights into how humans cope in extreme conditions. These examples remind us that while the challenges of living on Venus or Mars are immense, they're not insurmountable. But as we explore these solutions, we can't ignore the ethical questions they raise. Modifying human genetics, for instance, opens up a Pandora's box of moral dilemmas. Who gets access to these enhancements? What happens to those who choose not to modify themselves? And when it comes to terraforming, do we have the right to reshape an entire planet, even if it's for the sake of survival? These are questions that will shape not just the future of space exploration, but the future of humanity itself. As we push the boundaries of what's possible, one thing is clear: adapting to life on alien worlds will require more than just technological innovation. It will demand a rethinking of who we are, how we live, and what we're willing to sacrifice for the sake of exploration. And in that process, we might just discover new ways to thrive, not just on other planets, but right here on Earth. As we venture deeper into the realm of terraforming Venus and Mars, we must pause and confront a question that goes beyond the technical challenges: who owns the planets? This isn't just a philosophical debate, it's an ethical dilemma with profound implications for humanity's future. Think about it: if we transform an entire planet, do we have the right to claim it as our own? What if, in our quest to make these worlds habitable, we discover extraterrestrial life, even in microbial form? Would we have the moral authority to reshape an environment that isn't solely ours? These questions force us to grapple with our responsibilities as explorers and stewards of the cosmos. The ethical concerns don't stop there. Terraforming involves radical environmental changes, introducing new atmospheres, altering temperatures, and potentially erasing unique planetary features. Critics argue that this could be seen as a form of cosmic colonization, raising parallels to historical exploitation on Earth. Ethicists like Dr. Maria Alvarez have warned, we must tread carefully, ensuring that our actions in space reflect the best of humanity, not its worst. This sentiment echoes the need for a thoughtful, inclusive approach to planetary transformation. Adding to the complexity are the international laws governing space exploration. The Outer Space Treaty of 1967, signed by over 100 countries, declares that celestial bodies are the province of all mankind. This means no single nation can claim ownership of a planet. But as technology advances and private companies enter the space race, questions arise about how to enforce these principles. Will the benefits of terraforming be shared equitably, or will they be monopolized by the wealthiest nations and corporations? The stakes are high, and the need for global cooperation has never been more urgent. To navigate these challenges, we'll need more than just scientific innovation. We'll need ethical frameworks that prioritize fairness, sustainability, and respect for potential extraterrestrial ecosystems. Scientists like Dr. Raj Patel have called for a new era of cosmic diplomacy, where nations work together to establish guidelines for resource distribution and environmental preservation. This collaborative spirit could set a precedent for how humanity approaches not just space, but our shared future on Earth. And speaking of resources, this brings us to another critical layer of the terraforming conversation: the economics of reshaping planets. The financial investments required are staggering, but so are the potential rewards. How do we ensure that the costs and benefits are shared fairly across the globe? This question opens the door to a fascinating exploration of the economic implications of terraforming, which we'll dive into next. Now, let's take a step back and consider the economics of terraforming. It's not just about the science or the technology, it's also about the money. Transforming Venus or Mars into habitable worlds would require an investment so massive it's hard to wrap your head around. We're talking about costs that could rival the GDP of entire nations, if not more. But here's the thing, the potential returns could be equally staggering. So, is it worth it? Let's break it down. First, think about the initial costs. Terraforming would involve everything from deploying massive solar shields to redirect sunlight on Venus, to creating artificial magnetic fields to protect Mars from solar radiation. Then there's the infrastructure transporting materials, building habitats, and developing sustainable ecosystems. These aren't just one-time expenses, they're ongoing investments over decades, maybe even centuries. But here's where it gets interesting. Who pays for all this? One possibility is public-private partnerships. Governments could collaborate with private companies, sharing the financial burden while leveraging corporate innovation and efficiency. Space tourism could also play a role, generating revenue to fund these projects. Imagine wealthy individuals paying millions for a chance to visit a partially terraformed Mars. Sounds like science fiction, but it could become a reality. And then there are the economic benefits. Terraforming opens up access to extraterrestrial resources, metals, minerals, and even rare elements that are scarce on Earth. These resources could fuel industries back home, creating jobs and driving economic growth. Plus, expanding human civilization to other planets reduces the pressure on Earth's ecosystems, potentially mitigating some of the costs of climate change. To put this into perspective, let's look at some Earth-based examples. Large-scale infrastructure projects like the Panama Canal or the International Space Station required immense investments, but they've paid off in spades by enabling global trade and scientific discovery. Terraforming could follow a similar trajectory, with the added bonus of securing humanity's future on a cosmic scale. Of course, none of this happens overnight. Terraforming is a long-term endeavor, likely spanning centuries, but with careful planning and sustained investment, the economic benefits could far outweigh the costs. The question isn't just whether we can afford to terraform, it's whether we can afford not to. And speaking of timelines, how long would this actually take? That's a story for the next section. But just how long would it take to transform Venus and Mars into habitable worlds? The answer isn't measured in years or even decades. It's a journey spanning centuries. Terraforming these planets is a monumental task that will require breakthroughs we can't yet fully predict. But experts have sketched out a rough timeline that gives us a glimpse into what the future might hold. The first phase, already underway, involves research and exploration. Over the next few decades, missions to Venus and Mars will focus on gathering critical data, studying their atmospheres, mapping their surfaces, and identifying resources that could be used in the terraforming process. Think of this as laying the groundwork, the essential first steps before any large-scale changes can begin. Once we've gathered enough knowledge, the second phase kicks off: initial atmospheric manipulation. For Mars, this could mean releasing greenhouse gases trapped in its soil to thicken the atmosphere and raise temperatures. For Venus, it might involve deploying solar shields or chemical processes to cool the planet and break down its toxic atmosphere. Experts estimate this phase alone could take 100 to 200 years, depending on technological advancements and the scale of our efforts. The third phase is where things get truly transformative, creating a stable, Earth-like environment. On Mars, this would mean introducing microbes or genetically engineered organisms to produce oxygen and enrich the soil. On Venus, it could involve seeding the atmosphere with algae or other life forms to convert carbon dioxide into breathable air. These biological processes would take centuries to complete, gradually shifting the planets toward habitability. And finally, the fourth phase, full-scale human settlement. By this point, the atmospheres would be breathable, temperatures would be stable, and ecosystems would be thriving. But even then, the work isn't over. Maintaining these new environments would require ongoing effort, from regulating atmospheric composition to managing resources sustainably. What makes this timeline even more fascinating is the role of international collaboration. No single nation or organization could tackle this alone. It will take a global effort pooling resources, knowledge, and expertise across borders. The terraforming of Venus and Mars isn't just a scientific challenge, it's a unifying mission for humanity, one that could redefine our place in the cosmos. One of the most profound aspects of terraforming Venus and Mars is that it isn't just a scientific challenge, it's a human one. To reshape entire planets, we'll need something equally transformative: global cooperation on a scale never seen before. Think about it, this isn't a project that one nation or even a group of nations can tackle alone. It requires the combined efforts of scientists, engineers, governments, and organizations from every corner of the globe, all working toward a shared vision. But here's the catch: while the goal might be unified, the path to getting there is anything but simple. Different countries come to the table with vastly different priorities, resources, and political agendas. Some nations might prioritize economic growth, while others focus on environmental sustainability or national prestige. Bridging these gaps isn't just about signing treaties or sharing technology. It's about fostering trust and aligning incentives in a way that benefits everyone. Take the International Space Station, for example. It's one of humanity's greatest achievements in collaboration, bringing together nations like the United States, Russia, Japan, and members of the European Union. Despite geopolitical tensions, these countries have maintained a shared mission in space for decades. As astronaut Scott Kelly once said, "The International Space Station shows what humanity can accomplish when we work together, even under the most challenging circumstances." But terraforming is an even bigger leap. It's not just about maintaining a space station, it's about fundamentally altering entire worlds. That means coordinating massive infrastructure projects, resource allocation, and long-term planning across borders. And let's not forget the ethical considerations. Who gets to decide how these planets are shaped? Who benefits? These are questions that will require not just scientific expertise, but diplomacy and empathy on a global scale. Of course, the road ahead won't be without its risks. What happens if a key nation withdraws its support? What if technological advancements stall or resources run thin? These are real possibilities, and they highlight the fragility of such a monumental endeavor. But history has shown us that when humanity unites around a common goal, incredible things can happen. The Paris Agreement on climate change, the eradication of smallpox, and the development of the internet are all examples of what's possible when we pool our knowledge and resources. As we look to the stars, we're reminded that the challenges of terraforming aren't just about science and technology. They're about our ability to come together as a species. And while the risks of failure are real, so too are the rewards. Imagine a future where humanity, united by a shared purpose, transforms barren worlds into thriving havens. That's the kind of legacy worth striving for. But as we dream of that future, we must also confront the challenges that come with it, because the journey to reshaping planets will test not just our ingenuity, but our capacity for cooperation. As we venture into the ambitious realm of terraforming Venus and Mars, it's impossible to ignore the elephant in the room risk. After all, reshaping entire planets is no small feat, and with great ambition comes the potential for great challenges. What happens if a critical piece of technology fails? What if the atmospheric changes we initiate spiral out of control, creating unintended ecological consequences? These aren't just hypothetical questions, they're critical considerations that could make or break the success of any terraforming mission. One of the most pressing risks lies in the technology itself. Imagine deploying a massive solar shade to cool Venus, or a network of atmospheric processes to thicken Mars's air, only for a key system to malfunction. The fallout could range from minor setbacks to catastrophic failures, setting back progress by decades. To mitigate this, experts propose a phased implementation approach. Instead of going all in at once, we'd start with small-scale experiments, carefully monitoring each step and adjusting as needed. Think of it like building a house. You don't pour the foundation until you've tested the soil. But technological risks are just the beginning. Terraforming also carries the potential for ecological ripple effects. For instance, introducing Earth-like organisms to Mars could disrupt any native microbial life, if it exists, or create unforeseen imbalances in the developing ecosystem. Here, lessons from Earth's environmental disasters are invaluable. Take the introduction of cane toads to Australia in the 1930s. What began as an attempt to control pests led to an ecological nightmare as the toads multiplied uncontrollably, outcompeting native species. This cautionary tale reminds us that even well-intentioned interventions can have devastating consequences if not thoroughly thought through. So how do we prepare for the unknown? Contingency planning is key. Every step of the terraforming process should include backup plans, from redundant systems to alternative strategies if something goes wrong. For example, if a solar shade fails, we might rely on reflective aerosols to achieve similar cooling effects. Or if atmospheric processes break down, we could pivot to bioengineered organisms capable of producing oxygen. The goal is to build resilience into the system, ensuring that setbacks don't derail the entire mission. Ultimately, the path to terraforming isn't just about bold ideas and groundbreaking technology. It's about foresight, adaptability, and a deep respect for the complexities of planetary ecosystems. By learning from Earth's history and planning for the unexpected, we can approach this monumental task with both ambition and caution. And that brings us to the next piece of the puzzle, the importance of backup plans and how they'll play a crucial role in navigating the uncertainties of terraforming. So, what happens if terraforming Venus or Mars doesn't go as planned? It's a question worth asking, not because we lack confidence in the science, but because space exploration has always been about preparing for the unexpected. Even the most ambitious projects need a backup plan. If altering the atmospheres of these planets proves too challenging, there's another path: enclosed habitats. Think of them as life-supporting bubbles, self-sustaining ecosystems sealed off from the harsh environments outside. These habitats could serve as stepping stones, allowing humans to live and work on other planets without needing to transform the entire world. Imagine vast, interconnected domes filled with lush greenery, breathable air, and thriving communities. A miniature Earth on an alien landscape, but let's not stop there. If terraforming isn't feasible, we might shift our focus to other celestial bodies. Moons like Europa or Titan, with their unique environments, could offer opportunities for exploration and even habitation. Europa, with its subsurface ocean, might hold the key to extraterrestrial life, while Titan's thick atmosphere and methane lakes present a fascinating laboratory for scientific discovery. The universe is vast and our options are far from limited. Of course, none of this is easy, and history reminds us that failure is often the best teacher. Take, for example, Earth's own attempts at large-scale environmental engineering like the Aral Sea project. What began as an effort to divert rivers for agriculture led to one of the planet's worst ecological disasters. The lesson, flexibility and adaptability are critical. In space exploration, we must be ready to pivot, to learn from setbacks, and to embrace new strategies when needed. This adaptability isn't just about science, it's about culture too. Terraforming has captured the human imagination for decades, inspiring countless stories, films, and dreams of life beyond Earth. But what if the narrative shifts? What if, instead of reshaping worlds, we focus on coexisting with them? This shift could redefine our relationship with the cosmos, encouraging us to see ourselves not as conquerors of planets but as explorers and caretakers of the universe's wonders. The cultural impact of terraforming and its alternatives could shape how future generations view their place in the stars. Imagine a world where humanity no longer looks to Earth as its only home, where the red sands of Mars and the swirling clouds of Venus become as familiar as the oceans and forests we know today. Terraforming these worlds isn't just a scientific endeavor, it's a cultural revolution waiting to happen. As we reshape these planets, we'll inevitably reshape ourselves, our art, our stories, our beliefs. This isn't just about survival, it's about the evolution of what it means to be human. When we think about terraforming, we often focus on the technical challenges: how to create breathable air, how to regulate temperatures, how to grow food in alien soil. But what about the cultural challenges? What happens to our sense of identity when Earth is no longer the center of our existence? Cultural theorist Edward Soja once said, "Space is not just a physical container, it shapes and is shaped by the people who inhabit it." In other words, the places we live don't just house us, they define us. On Mars or Venus, humanity would face a profound shift in perspective. Imagine the art that could emerge from a civilization that sees two suns in the sky or watches dust storms dance across endless crimson plains. Literature would no longer be bound by Earth's landscapes. Instead, it might explore the existential questions of living on a world that humans themselves have remade. Philosophers might grapple with the ethics of reshaping an entire planet, while religions could evolve to incorporate the awe of standing on a world that was once inhospitable but is now alive with human presence. This blending of Earth-based traditions with extraterrestrial experiences could create a new planetary identity, one that unites humanity under a shared vision of exploration and transformation. But this shift won't happen overnight. It will require education to prepare future generations for the cultural and philosophical challenges of living on multiple worlds. Schools might one day teach not just the history of Earth, but the history of Mars and Venus as well. Students could learn about the pioneers who first set foot on these planets and the scientists who made them habitable. The process of terraforming will force us to confront questions we've never had to ask before. What does it mean to belong to a planet? How do we honor the traditions of Earth while embracing the possibilities of new worlds? These are the challenges that will define the next chapter of human culture, a chapter as vast and uncharted as the cosmos itself. As we look toward the stars and dream of turning barren worlds into thriving habitats, one question looms large: who will carry out this monumental task? The answer lies in the hands of the next generation. Preparing for a multi-planetary future isn't just about developing cutting-edge technology. It's about equipping young minds with the skills and knowledge to turn these visions into reality. Education, then, becomes the cornerstone of our interstellar ambitions. Across the globe, innovative programs are already laying the groundwork. STEM initiatives, science, technology, engineering, and mathematics are evolving to include space-focused curricula that inspire students to think beyond Earth. Take, for instance, the Mars Generation Student Space Ambassador Program, which empowers high schoolers to tackle real-world challenges like designing habitats for Mars or developing sustainable life support systems. These programs don't just teach technical skills, they cultivate creativity, problem-solving, and a sense of responsibility for the future of humanity. But it's not just about classrooms and textbooks. Hands-on experiences are proving to be a game-changer. Organizations like Space Camp and the Robotics Education and Competition Foundation are giving students the chance to build and launch their own rockets, program rovers, and even simulate space missions. These immersive experiences make the abstract concept of terraforming tangible, sparking curiosity and passion in ways traditional education often can't. By engaging students early, we're nurturing a generation that sees space not as a distant frontier, but as a canvas for innovation. The private sector is also stepping up to play a pivotal role. Companies like SpaceX and Blue Origin are partnering with schools and universities to create specialized programs that bridge the gap between academic theory and real-world application. SpaceX's Hyperloop Pod competition, for example, challenges students to design high-speed transportation systems, a skill set that could one day be applied to building infrastructure on Mars or Venus. These collaborations are more than just investments in education. They're investments in the future workforce that will drive the next era of space exploration. As we prepare for a future where humanity might call multiple planets home, education becomes our most powerful tool. By inspiring curiosity, fostering creativity, and equipping young minds with the skills to tackle the challenges of terraforming, we're not just teaching the next generation, we're empowering them to shape the destiny of our species. And as private companies continue to innovate and collaborate, the line between the classroom and the cosmos will only grow thinner, paving the way for a future where the stars are within reach. Space companies like SpaceX and Blue Origin aren't just redefining space travel, they're also playing a pivotal role in advancing the dream of terraforming Venus and Mars. These private sector giants are leveraging cutting-edge technology, deep pockets, and bold visions to tackle challenges that were once considered the exclusive domain of government agencies. But what's driving them? The motivations range from the pursuit of profit to a genuine belief in humanity's future as a multi-planetary species. Elon Musk, for instance, has famously stated that SpaceX's ultimate goal is to make life multiplanetary, calling it a backup plan for humanity. Meanwhile, Jeff Bezos has framed Blue Origin's mission as one of preserving Earth by moving heavy industry off-planet, creating what he calls a future of abundance. The contributions of these companies are already reshaping the landscape of terraforming research. SpaceX's Starship, designed to transport large payloads and eventually humans to Mars, could serve as a cornerstone for delivering the materials and infrastructure needed for large-scale planetary engineering. Blue Origin, on the other hand, is investing in technologies like solar reflectors and advanced propulsion systems, which could play a role in altering planetary atmospheres. And it's not just the big names, smaller startups are also entering the fray, developing innovative solutions like bioengineered microorganisms designed to thrive in harsh extraterrestrial environments. Recent breakthroughs are already hinting at what's possible. SpaceX's successful Starship test flights demonstrate the feasibility of reusable heavy-lift rockets, a critical step for transporting the massive resources required for terraforming. Blue Origin's work on lunar infrastructure could also serve as a testing ground for technologies that might later be adapted for Venus or Mars, but the road ahead isn't without challenges. Industry leaders have acknowledged the immense technical and ethical hurdles, from ensuring sustainable resource use to addressing the potential ecological impacts of altering another planet's environment. As these companies push forward, the potential for competition and even conflict looms on the horizon. With multiple players vying for influence and resources in space, questions arise about how collaboration and competition will shape the future of terraforming. Will these companies work together to achieve a shared vision, or will their rivalries slow progress? Only time will tell, but one thing is certain: the private sector's role in this grand endeavor is just beginning to unfold. As humanity sets its sights on transforming the barren landscapes of Venus and Mars into habitable worlds, a new kind of space race is emerging, one that could reshape the future of our species. But with such monumental ambitions come inevitable challenges, and at the forefront of these is the potential for competition and conflict. Picture this: multiple nations and private corporations racing to establish dominance over the resources and technologies needed to terraform these planets. It's not hard to see how this could lead to disputes, rivalries, and even geopolitical tensions reminiscent of the Cold War space race, but on a much larger scale. The stakes are incredibly high. Both Venus and Mars hold vast reserves of valuable resources, from rare minerals to potential sources of energy. On Earth, we've seen how competition for resources can lead to conflict, and the same risks apply here. Imagine two nations or corporations claiming overlapping territories on Mars, each vying for control of a critical water source or mineral deposit. Without clear rules and agreements, these disputes could escalate, threatening the very progress we're trying to achieve. History offers us some important lessons. During the Cold War, the United States and the Soviet Union engaged in a fierce competition to reach the moon. While this rivalry drove incredible advancements in technology, it also created significant tensions and risks. Today, as we look to terraform other planets, we have the opportunity to learn from these past experiences. Establishing clear regulations and conflict resolution mechanisms will be essential to prevent history from repeating itself. International cooperation will play a crucial role in ensuring that the race to transform Venus and Mars doesn't become a zero-sum game. But beyond the risks lies an opportunity, a chance to redefine how we approach exploration and innovation. Imagine a future where nations and corporations work together, not just to claim territory or resources, but to create a shared vision for humanity's future among the stars. This vision could unite us in ways we've never seen before, turning the challenges of today into the triumphs of tomorrow. The question isn't just about who will get there first, but how we can all get there together. The road ahead is complex, but by navigating these challenges thoughtfully, we can ensure that the journey to terraform Venus and Mars becomes a testament to human ingenuity, cooperation, and shared purpose. And as we take these bold steps, we're not just shaping the future of these planets, we're shaping the future of humanity itself. As we look to the stars and dream of transforming worlds like Venus and Mars, one thing becomes abundantly clear: our greatest challenge isn't just technical, it's collective. To truly succeed in terraforming, we need more than cutting-edge technology and scientific breakthroughs. We need a shared vision, a common dream that unites humanity in the pursuit of a brighter future. This vision isn't something that can be built in a lab or calculated on a spreadsheet. It's something that must be cultivated through the power of storytelling, art, and media. Think about the stories that have inspired generations' tales of exploration, courage, and the triumph of human ingenuity. From Jules Verne's From the Earth to the Moon to the cinematic wonders of The Martian, these narratives don't just entertain, they ignite our imaginations and remind us of what's possible. Art and media have a unique ability to make the abstract tangible. A painting of a terraformed Mars with its lush green valleys and shimmering blue lakes can evoke emotions that a scientific paper simply can't. A documentary exploring the challenges and triumphs of space colonization can bring the realities of this endeavor into living rooms around the world. These creative expressions don't just inform, they inspire, sparking a sense of wonder and possibility that transcends borders, cultures, and generations. And let's not underestimate the role of hope in this shared vision. Terraforming isn't just about changing planets, it's about changing perspectives. It's a reminder that even the most daunting challenges can be overcome when we work together. As Carl Sagan once said, "The visions we offer our children shape the future. It matters what those visions are." By envisioning a future where humanity thrives among the stars, we plant the seeds of unity and collaboration that will carry us forward. This shared vision also has the power to bridge divides. In a world often fragmented by differences, the Dream of Terraforming offers a common goal, a chance to redefine what it means to be human. It's a reminder that, no matter where we come from, we are all passengers on this pale blue dot with the potential to reach for something greater. So, as we continue to explore the possibilities of terraforming Venus and Mars, let's also invest in the stories, art, and ideas that will shape our collective journey. Because the future isn't just something we build, it's something we imagine together. And in that shared imagination, we find the hope, unity, and inspiration needed to turn science fiction into science fact. As we reflect on the incredible journey we've taken together, let's revisit the key ideas that have shaped our exploration of terraforming Venus and Mars. From groundbreaking technologies like atmospheric processors and magnetic shields to the visionary concepts of artificial photosynthesis and geothermal energy, we've seen how humanity's ingenuity could transform these barren worlds into livable environments. But it's not just about the science, it's about the bigger picture. We've also grappled with the ethical questions of who gets to benefit from these advancements and how we ensure that the mistakes of Earth's past aren't repeated on other planets. The cultural implications are just as profound, as terraforming could redefine what it means to be human, pushing us to adapt to entirely new ways of living and thriving. What ties all of these threads together is the urgent need for solutions to Earth's own challenges. Terraforming isn't just about escaping our problems, it's about learning how to solve them. By studying how to create sustainable ecosystems on other worlds, we gain insights that could help us heal and protect our own planet. It's a reminder that innovation and responsibility must go hand in hand, whether we're reshaping the skies of Venus or the deserts of Mars. As we prepare to wrap up this exploration, let's carry these lessons forward, thinking not just about the possibilities of the future, but also about the choices we make today. As we stand on the brink of humanity's next great leap, the idea of terraforming Venus and Mars isn't just a dream, it's a call to action. These planets, once seen as barren and inhospitable, could become the next frontiers of human civilization, thanks to the power of innovation, collaboration, and bold vision. Think about it, transforming a planet like Mars with its thin atmosphere and freezing temperatures, or Venus with its crushing pressure and scorching heat, into habitable worlds is no small feat. But history has shown us that what seems impossible today can become reality tomorrow. The key lies in our ability to think beyond the limits of our current technology and to work together across borders, disciplines, and generations. Every breakthrough in energy, materials science, and planetary engineering brings us one step closer to making these worlds livable. And while the challenges are immense, so too are the rewards. Imagine a future where humanity thrives not just on Earth but among the stars. A future where we've expanded our horizons and secured our survival by becoming a multi-planetary species. This vision isn't just for scientists or engineers, it's for all of us. Each of us has a role to play in shaping this future, whether by supporting advancements in technology, advocating for space exploration, or simply daring to dream big. As Carl Sagan once said, somewhere something incredible is waiting to be known. What if that something is a new home for humanity waiting for us to bring it to life? Now I want to hear from you. What excites you most about the possibility of terraforming Venus or Mars? Do you see yourself as part of this future? Share your thoughts in the comments below. I'd love to hear your ideas and spark a conversation. And if you're as fascinated by the possibilities of futuristic technology as I am, don't forget to subscribe and hit the notification bell so you never miss an update. Together, let's keep exploring the incredible potential of tomorrow. The future is out there, let's go meet it.